I am Mr. Auerbach. I am going to talk to you about the science now, and today is our final installment of Climate and the Carbon Cycle, where we're going to talk about climate and the carbon cycle. And finally, we've set the stage so far. We have talked about what substances are in the atmosphere. We've talked about how much carbon is in different parts of the atmosphere, lithosphere, and hydrosphere. We've talked about exchange between the atmosphere and land, between the ocean and the land, and between the atmosphere and the rock cycle as far as chemical weathering and volcanoes and whatnot. And now we're going to talk about the issue, which is the imbalance. This is sort of the big part. So I guess, well, I've had a picture of the Earth here throughout all the rest of this, so I feel uncomfortable not having it again. I don't know if we'll actually need it. You can be pretty sure that I'll erase it in just a second. But let's see. So we have actually, yep, I was right. I'm going to erase it right now. We had the diagram before that was talking about the exchanges between various parts. I'm going to sort of shorthand it: ocean and deep ocean, land, atmosphere. And what we talked about is that everything's roughly in balance. I think it's 120 gigatons of carbon go back and forth between the land and the atmosphere in the form of decay and cellular respiration, bringing it out, photosynthesis, bringing it back to the land. The ocean, I think, was it 80 or 85? Does anybody remember offhand?
It was 80.
80, thank you. 80 gigatons of carbon going back and forth between the atmosphere and the ocean. And then there was the whole thing, deep ocean and the permafrost. We'll just forget about that for right now. What the point is, most of this stuff is in balance, except for one thing: the fossil fuels. Right? We'll talk a little bit more about how it couldn't possibly be anything else, because it really couldn't possibly be anything else. But hello, I'm Mr. Auerbach. So, imbalance. Where does it come from? The fossil fuels, burning the fossil fuels. We had talked about how the exchange between the rock cycle, I'll put rocks over here because they're deeper than the land, rock cycle, that at current time, really not so much. We've got, let's see, between the land and the atmosphere, we have about 0.1 gigatons per year of chemical weathering going on, muchly due to the vast expanse of silicate rock in the Himalayas, and then volcanic activity, which is the only way that carbon dioxide gets from the rocks back into the atmosphere, also about 0.1 gigatons. But there is another way to get material from the rocks cycle back into the atmosphere, and that is the fossil fuels. Because you've got the fossil fuels, we'll just use that to stand for the fossil fuels. I think you get the point. They're giving off the carbon dioxide, which, even though it's an invisible gas, I will draw it in black marker because I can't draw it in invisible gas. We're putting about, well, overall it's about a 9.1 gigaton load into the atmosphere every year. Turns out that about 8.3 gigatons, let's do this in red because it's the new part we're talking about and everything's getting a little crowded here. 8.3 gigatons going into the atmosphere from the fossil fuel combustion. Of course, this isn't all from burning coal. This comes from our cars. This comes from everything that we've done since sort of the Industrial Revolution. I mean, it also comes from burning wood. When you burn wood, you're also adding carbon dioxide to the atmosphere. We can talk about which of these is most least involved, but absolutely, we're putting 8.3 gigatons in. And the other thing is that Does anybody know, we've talked about, there's sort of one other way that we're actually causing a change that it doesn't add more to the atmosphere, it causes us to take less back out, which is, okay, now I'm just setting up this up as a big...
And for like depleting sinks, is that a thing?
Depleting sinks, yes, right, like, but yeah, sinks, carbon sinks, like, for example, oh, I've lost my brown marker.
Like a forest?
Like a forest, yeah, the brown marker was definitely the clue. So, okay, so these are trees, right? And we know that trees are taking in the carbon dioxide. That is what they do. That's their job. They love carbon dioxide. They also put out the oxygen, as we know. This is not 7th grade science, you know that. But you also are probably pretty aware that when you cut down significant parts of the forest, as we have cut down significant parts of the forest, I don't think there's any controversy to say that. We're cutting down, I'm going to insert the proper amount in that part of the video, per year. That turns out to not add, but it turns out to not subtract about 0.9 gigatons per year. So almost a full gigaton of carbon that would be removed from the atmosphere is not being removed from the atmosphere per year because of deforestation. Yes?
Oh, specifically deforestation.
Yes, specifically because of deforestation, yes. And so that's the general picture of the balance of things. And I mean, you can find much more granular analysis of these things on the IPCC and you know, other places. But that's the big picture, yes.
Are there other sinks?
Are there other sinks?
Like, is what?
Like a bog.
Well, let me think about that. Actually, bogs tend to produce bogs produce methane, which is definitely a thing. Well, the thing is, the oil is technically part of the rock cycle. So yeah, in a way, like it is. It's carbon that's sequestered.
Right.
But we're just sort of doing the opposite. Yeah, we're releasing the carbon sink. We're sort of taking a carbon sink and setting it free into the atmosphere. I guess I mean, I know you understand that. I meant to make that more clear, but yes, it is. This movement of carbon dioxide is like basically like, you know, volcanoes, except with the stuff that we can burn. You're taking stuff that was more or less permanently part of the rock system, part of the underground system, that never would have seen the light of day again, probably barring, you know, land moving, land building exercises.